think this is it. There it is. Okay. Do you guys see the Elli logo on the
Yep,
screen?
yep,
Yes.
yep.
All
Yep.
right. Excellent. All right. So let's go ahead and I'm going to play this. And like I said, if you have any questions, then just shout them out and we'll go from
Okay.
there. So this is the light sources class. This is session one, the first of two, and each are pre-recorded with Tom Garber and myself. And here we go. All right, here we are. Thank you for joining us today. We're going to have our course session begins on light sources. This will be a two-part program, and I'm here with our special guest and expert in LEDs, Tom Garber from Emery-Allen, who has at least 35 years experience working within this profession, and we're fortunate to have him on board to give us some feedback and insight as it applies to light sources, especially with LEDs today. So what we're going to do in this is we're going to run through our program, and we'll talk about the new technology, we'll talk about old technology, the importance of quality and light, and then we'll also talk about maybe some of the weaknesses within light fixtures and then the different standards that are applied to measure quality and such. So let me share the screen and we will get rolling here. All right, here we go.
Good deal. Well, thanks, Mark. I appreciate you inviting me to be a part of this. Something that's always been near and dear to my heart. So,
Can you see that okay, Tom?
yeah, everything's good.
Awesome. All right, let's go to our first slide here. Basically, in session one, we're going to have this short introduction. We're going to talk about current and old technology. We felt like the old technology is important because we've got to know a little bit where we came from, and it wasn't too far back. I think pre 2014 we had halogen, xenon, and other like incandescent type technology. So we wanted to show a few of those things. And then what the options are for LEDs today between retrofit, modular, and integrated. And then we'll end with lighting metrics, and then we'll shift to session two. So the light source is the most important part of a lighting system. It's kind of like the heart. You can't produce and create without the light, obviously. And the fixture is the housing that helps to protect the light source.
Yeah, and this is what I've always said. It's what's on the inside that counts. No matter how beautiful your fixture is, if you have a poor light source on the inside, that's what the ultimate result's going to be.
Sure. No, that's great. We just switched over to this terminology slide. Can you talk a little bit about color rendering index, CRI, and why that's important?
Sure. So the CRI index, basically goes from 0 to 100. The 100 being, natural daylight, also is reflected by halogen lamps as well, where they will be, 98, 99 on the CRI scale, and it takes into consideration 13 different color reference points. And so that's what, and later on as we get into that, we'll see all those different reference points, but CRI only uses 8 out of those 13, which it gives you the final number. It's just an average of everything added together. So, we like to say that with all LED lamps, LED fixtures, integrated or whatever, that we want to maintain above a 90 CRI. Once you get above that, it gets to be a little bit difficult because you start losing lumens and all, and I can explain that later. Once you get below 90, things will get a little bit grayed out. They don't look as clean, as clear, as crisp. So 90 is the hot spot. 90 is our goal, whether that's outside doing landscape lighting or if that's on the inside as well.
Right. Hey, I got a question for you. I had heard that CRI was expanding their different tests in terms of, is that true, or am I just being misled on that? In terms of different colors, adding more instead of just 9 or 13, is that expanding to include more colors?
So that's considered into TM30.
Okay.
TM30 is going to take the place of CRI. And I've talked to the people at American Lighting Association, IES, and all of that. And it sounds like that's going to take a while to do. Everybody agrees that's the right direction, but implementation of that is probably, 10 or 15 years out. Now, full implementation has to do with also canceling out the current indexing mark, but it's a good thing to always look at when you're looking at light, and we'll get into that a little bit more later as well.
Okay, awesome. Two other terms that are important to understand, or at least generally speaking, is illuminance and luminance. They can be a little bit confusing. A lot of the terms that are used to study light, you get into formulas and different metrics that seem confusing, but basically illuminance is the amount of light falling onto an object or illuminating a given surface. Whereas luminance is the amount of light or intensity reflected off of an object. You can also look at it as how we perceive the light based off of what we're seeing. So let's look at the next slide here. This gives you a little visual description or understanding of that. So you can see here the light source, which is the table lamp. Luminous flux is the total lumens that are coming out off of that. And the luminous intensity is understood as candelas, which is another form of lumens, I guess. And then the illuminance is where it's, directed at an area like that, where it's lumens per meter squared. And that's what lux is. Again, when you get into these different terms, I would just suggest that you take this and research it on your own and try to understand if you want to go this deep. But it's this is what the IES uses, a lot of these different metrics. Luminance, remember we mentioned about it's what we see or what we perceive, and that's what the eyeball is, what we're seeing reflected back to us.
You know where this is really important, Mark, I think, is if anybody gets into any type of commercial work, you'll get lighting engineers or designers asking you for an IES file because, they have to produce X amount of lumens or candelas on a surface in a public space. Right. So that's where I think a lot of this stuff really gets to be real important. But, honestly, something like this, we might be asked for those types of files like 5 or 6 times a year, and that's about it. Right. And I think maybe another good way that we can look at it as landscape lighters is what we're seeing. If we're trying to highlight or to illuminate a subject and we need that intensity to be stronger, then we have to consider, well, what's the materials? Is the light reflecting or absorbing?
off of that subject matter. And, you know, light will react differently with all the different materials. So we have to, that's where some of this understanding comes in, where we can, okay, we need so many lumens to basically make that stand out to a 3-to-1 ratio or something along that lines. So anyways. Okay, here's some more terminology. I'll let Tom, why don't you explain power factor and volt amperes?
So, power factor and volt amperes, also known as VA, are directly related to each other. The higher the power factor, the lower the VA. The higher the VA, the lower the power factor. You know, it's, I guess you look at this in terms of like wasted energy. And, you know, so I was kind of talking to Mark yesterday about this, you know, picture that mug of beer, right? And the mug of beer has 3/4 of it that's full of beer and 1/4 of it that's got foam. Think of that foam as the wasted energy. You know, the more beer in that glass, just like it's the higher the power factor. And so basically with a bulb or a you know, integrated fixture or something like that, depending on the circuit design, you can have wasted energy. Wasted energy is the amount of energy that is not attributing to that device, fixture, bulb, or whatever that's lighting up. You lose a lot of that energy, that wasted energy in the circuit.
Where'd the audio go?
Something happened, yeah.
Why is it important? You know, I could have two 7-watt MR16s. One has again, they're two rated at 7-watt MR16. One has a VA rating of 11, and the other one is like 7.5. So you could be wasting over 50% of the energy in that wasted energy. But guess what? That's what that 11 watts, that 7 plus 4 give you 11, that 4 watts is still being captured by the transformer. So in this particular case, you can put 3 7-watt MR16s on the transformer, and it would be drawing the same amount as 2 of the products that have a very high VA or low power factor. And I'll show you on the charts later on what that looks like.
So that can impact basically the capacity of the transformer overall, like how much you can load up on there. If you're thinking, well, I only have 200 watts on this 300-watt transformer, but with VA, if you have poor quality LEDs, that actually maybe it jumps up to 240 or something like that instead of right? Is that kind of what you're saying?
Also you got to look at voltage drop. That has a definite effect on voltage drop as well. So you just have to be careful about that. And, you know, we should be striving to get a power factor as close to 0.99 as possible, and a volt ampere rating as close to the wattage of the actual bulb. I mean, those are ideal. They might not be achievable, but you can get close.
Great. How does that now compare to efficacy with, you know, lumens per watt?
So, with efficacy, and again, we can see on some of the charts, if a bulb is drawing 100, or say you have 100 lumens, and that bulb is pulling 2 watts, including VA. So the efficacy of that lumens divided by watts is you would be producing 50 lumens per watt. So you'll, a lot of times you don't hear of that said in terms of efficacy. You might say lumens per watt, and people get, I don't want you to get confused or anything, but that's exactly what that means. It's the overall amount of lumens divided by the wattage.
Great, thank you. So you've got lumens and foot candles on here. Foot candles is a measurement that a lot of people were used to in the past, where it's lumens per square foot. And 1 foot candle is equal to 10.76 lux. And lux addresses area, so a square meter. So a little confusing, but it's just, in the US here, we use foot candles a lot. Internationally, they're using, other measurements or lux and such. So, all right, let's go on here to the last thing for terminology. I mean, I threw in Ohm's law here so that we can understand this relationship between 3 different parts. So you have power, which is basically, it can be watts, and then you have current, which is I, or amperage, and then you have energy, E, which is voltage. And then I show this inverse relationship in these formulas. You have 3 formulas here, and then you can use those formulas depending on what you're trying to determine for whether you're trying to figure out what the amps are on the primary side right out of before the transformer, or the secondary side, down line of the transformer. And, you can use these formulas to calculate what's missing. So if you know 2 of them, like I have 120 volts coming out of the receptacle into the transformer, and we have 64 watts on the system as an example. And that's drawing, the power there is, it's 0.53 amps at the transformer. Now, if it was the secondary side coming out of the transformer to the light fixtures, which is 12 volts, then you can see your amperage is going to jump up. And typically most transformers are about a 10-to-1 ratio. So that would be about 5.3 amps instead with the 12 volts. So again, this is just the basic formula. We're going to cover this in other courses when we get into cable design, distribution, and where we talk more about Ohm's law and voltage drop and such. But I wanted to share this. Do you have any other comments here, Tom, on this?
No, I think the most common place that you would use something like this is if you were just looking at the draw on a home run, going back to the transformer. We put a ammeter on on the current side, and you're reading the amount of amps, and then you see what the voltage is. You can calculate what the wattage of that system is. So it works in a lot of different ways.
Right. Great. Thank you. Okay, light source technologies, because this is primarily low voltage 12-volt lighting systems that we work with. You have LEDs, light emitting diodes, and we talked about this. There's 3 different types that are out there today. And correct me if I'm wrong, Tom, so you just throw in, but basically retrofit or drop-in units, which is primarily what you offer at Emery-Allen, right?
Right.
And then we have modular or replaceable type units, and then there's integrated, where it's all inclusive, where if something goes wrong with the integrated package, then you basically have to dispose of the whole unit. So, and then the old school lamps, we talked about incandescent, halogen, and xenon. And that was prior to 2014, stuff that we all kind of grew up on back when we used to do these systems. So here, for example, showing like a little picture of various old school incandescent, halogen, or xenon lamps. And it just basically the shape or the form. So R36, they're still used in retrofit. We'll show that next. You know, most of these lamps here, the same types of designs are still used for the retrofit market. So now you've got compact fluorescent. Are they using much of that anymore, Tom, that you know of? I don't think so, but
I mean, I get calls for replacement LED packages that will fit into a compact fluorescent socket occasionally. I know that they were using compact fluorescents for wall washers way back when.
yes.
I haven't seen that on a landscape fixture for almost ever. But one of the things that's, you know, interesting, you show this picture, is that you know, you have each of these different types of lamps and the acronym associated with it. PAR is parabolic aluminized reflector. This is an old headlamp, right? I mean, they didn't make light bulbs specifically for landscape lighting, and so where did they get them? Well, we got them all from, you know, the automotive industry, and we still call a PAR 36 a PAR 36, even though it's LED, and it has nothing to do with parabolic aluminized reflector, and none of that stuff like works anymore. Same with MR16s or MR11s. It's mirrored.
Mirror reflector, yeah.
Yeah, yes, and it's you know, the only thing that sticks there is the 16, which is 16 1/8 of an inches, in which like all bulbs are still somewhat measured. PAR 36, it's 36 1/8 of an inches in diameter, and that's when you get into some of the bipins and the wedge base, where it will call T. T is tubular. The 3 is 3/8 of an inch, typically in diameter. And now people kind of throw those terms all out there, and they really don't mean all that much. And they certainly have no reference to the halogen or incandescent bulbs that were their parents, you know, long, long ago.
Right. Excellent. Thank you. So we already talked about this. This is just an extra piece. Here's some examples of these. This is all part of the Emery-Allen display here of, you know, the similar PAR 36, like Tom was just explaining, MR16, MR8, MR11s. And that's just part of this design here. Here's another set. You can see what they look like with regards to bipins or wedges, and festoon, which is an old school. I remember they used to use those in like the old step lights and such, or those little niche lights.
I think the original use of a festoon lamp was the light in the headliner of your car.
Oh, that's,
Got hand so many times on those.
70s, pop that thing out, and you'd have a little festoon. That's where I believe that originally came from.
how about that?
And
Yeah.
then it went from there to the interiors, and they were used with there's a company out there called Seagull Lighting, and they came up with an ambiance under cabinet lighting that used all festoon lamps. And
Like a strip light or linear, right?
Right, and that was very popular then, and people used it underneath their cabinets, on top of their cabinets, or as toe kicks. And you don't see too much of that anymore because you can basically achieve the same thing in, you know, bulbs like LMWs or wedge-based bulbs or whatever.
Can you tell us a little bit about the LMWs? Because that's a newer one that you don't see as much as the other old common ones.
Actually, LMW is something that we developed specifically for Hinckley. And it's, if you would have a side view of that, you would see that it's a linear bulb that, you know, all of the LEDs are on one side of the housing and it only goes, you know, in that direction. It's not a directional lamp, it's still a, because it's of the size of it, it's a little bit longer than it is narrow. We just came up with the terminology as being a linear mini wedge and works great with wall washes, works great with under cabinet lights, little puck lights. Oh, what the heck?
Probably low profile path lights where they have not much.
Absolutely. I mean, that's a nice little, you know, little package, less than about a quarter of an inch thick.
Yeah.
And puts out an awful lot of light, but it's been a very popular bulb for us, linear mini wedge.
Great. Now, you see over here the single contact SCB, DCB, single contact bayonet, dual contact bayonet. I remember using a lot of the dual contact bayonets with it was like in an AR-11 or AR-12. I can't remember what the technology was called back then.
Yeah,
I mean, frosted glass lens.
Right, the ARs, and I think you had an example back on your incandescent page, but what we do is single contact bayonet, we isolate specifically for low voltage, and the double contact bayonet we can have for both low and line voltage. There are some people that want the single contact bayonets in 120 volt, and there are some rules written that you can't do this anymore. If you imagine if somebody miswires something and gets the polarity switched around, the screw shell on that could be charged with, you know, the positive current. And, you know, people have gotten shocked and whatever. That's happened on a lot of other types of lights. So we really look at safety on all of this. And so for this application of a single contact where a person could possibly shock themselves, we won't do it. It's strictly for the double contact.
Got it. Awesome. Yeah, let me go back. I'll show you that here. So up here, the AR-11.
There you go.
Old school. I remember I used to use those in some old downlights, and then I've seen them in elevators before, where it's up in the ceiling. So
yeah, and I think that those are most popular now in elevator lights. And I believe there's a couple of landscape companies that still use that. I believe that Focus was one of them. And I think Beachside Lighting out of Hawaii was another one that used that.
FX Luminaire did. I remember them. Yeah. So interesting. So here's the other ones that we may run across in landscape lighting, the E12 and the E26 style lamps, which have been converted to LEDs now. So these mini ones, they're smaller ones, are for like chandeliers and sconces, coach lights, and then wall sconces, coach lights for these other ones. Now, do you offer those in also frosted glass or the shell, the bulb?
The E12 we offer in frosted. The other one, which is a little bistro lamp,
Oh, okay.
We don't, just because we've asked about it. Do you want this, that, and so, no, this has got to be for bistro lights. And that's what we're talking about here is, these are available in 12 volts. So the one on the right, the E26 version is a bistro light. It's called an S14, available in 12 and 120 volt. And we really we underdrive that. So they're only putting out about 80 lumens or so. And then the E12, again, a lot of times what people do when they're doing landscape jobs is they'll convert the post light that people have. They'll bypass, they'll cap off the 120 volt and they'll run 12 volt up the post, and they'll convert that to 12 volt. Primarily, the energy savings, and then number two, these will last an awful lot longer than a 12 volt or a 120 volt bulb. So cost savings, longevity, and all that just works out a lot better.
Great. Thank you. So here's some couple examples that I could find on modular LEDs, just so you have an understanding. These are field changeable or replaceable, which makes it nice, just like the retrofits, to where if you have a problem with the LED package, then you can get that changed or fixed in the, like I said, in the field or back at the shop, versus having to have a new one sent to you from a manufacturer or get a whole new fixture unit. So I show an example of the Gambino landscape lighting. He had his own products made. He's been doing that for a long time. This is an old version of his. It's not his current version, but just to show you, you have the optics here, and then you have this screw-on shell. There's an O-ring, this is all aluminum. And then on the back side, he had one of the first toggle switches for different settings, almost like this other one up here where you can go with different wattage levels, lumen outputs, basically. This one's an Excelsior module, same basic design or understanding, and they offer like 4 different, light levels, or no, I shouldn't say light levels, but color temperature, 2700, 3000, 4000. So, and they also have, again, this is where the light levels are in the.
Mark, on these Excelsiors, I've seen those types of modules, but on Gambinos, how long has he had those out?
He's been doing this since when LED first started. I don't think it was right around 07, 08, but I know close to 2010, he had the products being made for him way back. And then he basically has been upgrading this ever since. I believe his current modular setup is all brass now, or mostly brass, not aluminum or whatever, but he's got the original ones. I think he first had, there was like toggle switches on the inside under the cap for the different wattage settings. Again, this was, way back. I'm sure I could get a series of all his old products to kind of display, but he was one of the guys back in the early days that was really pushing this, as many other companies were too. I don't know who got what technology from who, that's a whole nother question. Who started, who was the first to do it? I don't know. So, okay. But I just wanted to show here what a modular type unit looks like, so that people, if they want to go this route, this is an option. So, and then integrated, what we have here is basically everything's built into the fixture housing. So the LEDs are all internal, and this is just one example. This one's by Sterling Lighting, the 2 different examples of wash light and uplight. But again, I'm not sure if these are field changeable, the LED units inside. But most of the integrated, from what I believe, you have to basically ditch the whole unit and buy a new one or get a new one to replace it. Is that about right, Tom? Do you have any?
Yeah, I was at I forget what the event that I was at, and I was talking to Pat and Damien. And I thought one of the benefits of the Sterling products is that those integrated parts were replaceable. They had.
Oh, okay, so kind of modular in a sense, okay.
Yeah. And
They are replaceable.
great that they were doing.
Good, excellent. Why don't I don't know if you want to comment on any of this. Basically, I've tried to put retrofit LEDs versus integrated as advantages versus disadvantages. And modular kind of falls in between. There's both on both sides. So, do you want to talk about anything here? What do you think are the advantages versus disadvantages to retrofits over the others?
I never really did a one-to-one cost comparison for you take a good quality product and you put a drop-in or a retrofit lamp inside of it, and then you do a cost comparison with an integrated, and I'm not sure where that comes out. And I have a feeling, if you take something like let me say like an Aurora Light product, which is a very high-end product anyway.
Yeah.
And you put our lamp in it, which they have retrofits, and then if they have another version, but if you look at the cost of the two, how similar that they would be. And I think then if you go to the opposite end and you've got a very, very inexpensive unit, by the time you put a retrofit lamp in it, you could almost double the cost. So I don't know, there's a whole cost versus quality type of thing going on. But one of the things that especially with a lot of our customers that are very, very particular about color and are particular about being able to change color and change the amount of the brightness or something like that. And it's very easy to do with lamps, and with integrated, it's a little bit more difficult. You can't dial things in as close on an integrated than you can in the retrofit LED.
Right.
Disadvantages: limited lumen output. I would say that we're probably going to max out with today's technology at about maybe 850 lumens max. But this is a clear advantage of integrated, is if everything is designed properly. I mean, you're not buying some off the shelf thing that somebody from China had put together, and a lot of thought is put into this. You can get the same size of MR16 fixture, maybe a little bit bigger. You can get 1100, 1200 lumens out of it without any problem, just because of the way that the thermal management or the temperature is being managed properly, so it's dissipating. Because that's the biggest thing that's killing these things is the heat at this point. So that's the biggest advantage to integrated, or disadvantage over retrofit LEDs. We're limited based on the size and all of that.
Right. Yeah. I think as a lighting designer, I prefer retrofits personally, just because I like to have the designer's control of, like you said, with the various colors, with the outputs, and I want to have that as part of my package versus something that maybe would provide a little bit less of an options for me.
Sure.
So like, everybody's a little different. And, I think, it's a good thing to think about these different options. So if we go to the next one, integrated, that's basically still included. I'm gonna have all this information available to you guys as part of a study guide. So we don't have to read through every little bit and piece, but lighting metrics, they're used to understand and to predict how a lighting system will operate. So we're looking at quantity of light, light output and light levels, quality of light, which is the brightness and color, and then fixture efficiency, which is the electrical efficiency, and how much light leaves the fixture. Do you have any thoughts or insights here, Tom, about any of this and its importance?
I think we'll get into that in some of the upcoming slides.
Okay.
Yeah, I have a lot to say about this, and I think they're just better addressed on the other slides.
Okay, let's do that then. Perfect. So here's the section that has more of your slides, Tom. Why don't we run here forward with you kind of leading us here?
Sure. I mean, I look at our challenges as a bulb manufacturer, lamp manufacturer, whatever you want to call it, is, it's not it's not that we're trying to beat out our competitors or this guy or that guy or whatever. It's like we want to focus on what the real prize is here, and that's what we go after. The prize is to be able to produce a product that produces light as close to halogen or sunlight as possible. In terms of color, we can take the advantages of the LEDs, the efficiencies and all of that, but in terms of color, that's what our goal is.
Excellent. Okay.
So here is an example of a 10-watt halogen lamp. I mean, when you fire up, 10-watt halogen, it's got a tungsten filament, the pins, the filament and all of that. Tungsten burns at a very, very precise color when a certain amount of voltage and heat is applied to it. It gives you this beautiful curve from violets, all the way up to, dark, deep reds and all of that. And the biggest challenges for us, and you'll see in other slides, is to be able to produce reds in quantity, and all of that is a little bit more challenging, and something that we battle on a daily basis. So here it is. This is our goal right here.
Okay.
So this obviously isn't without some problems. We're looking at from a color standpoint. As we said, you look at all of the rendering indices on the right hand side. They're about as close to 100 as possible. But then on the other hand, you look at the other side, and the luminous flux, remember we talked about that, is you're at, this lamp is putting out 80 lumens. The efficacy is 7.75 lumens per watt. The power factor is perfect. You're putting 12 volts into this thing, and there's no wasted energy here at all. I mean, you're firing up this tungsten element to best of its ability. You drop down here and you look at the VA. It's a 10-watt bulb. This is producing 10.38 VA. The actual power that's going into it, that's producing light, is 10.35. So would you say, overall loss is 0.03? And I would say that there's some tolerance probably built into that. So it's very, very efficient in terms of what goes in is being used to produce light. Obviously, where you're losing out things is in the luminous flux, the amount of lumens and the lumens per watt.
Mhm.
So this is something we talked about earlier. This is what eventually is going to wind up replacing CRI, and this is TM30. And basically, there is a black circle and then a red circle on top of it. The red circle represents the 10-watt halogen bulb, and it lays perfectly on top of that black reference circle, which is like we talked about 100, and that just gives you the perfect color that's really achievable.
Great.
So then, we talk about, that circle. And if that circle starts shifting one way or the other, you look at the center tomato, and if you get something to shift, a color to shift up or down, that will get to be a little bit more orange or oversaturated, a little bit more pink or whatever. So it's all about trying to balance all of those colors to give you as close to that reference color as possible.
Great.
So here, for instance, is our 7-watt MR16, and obviously we still have some work to do on this, trying to balance this out as much as possible. But to be quite honest with you, this is probably one of the better looking charts for, this is a 92, I believe, CRI lamp. As I mentioned before, where we fail, where everybody fails down in the R9, the reds, where things drop down a little bit. We'd like to see things smooth out. But some interesting facts about that is if you can add different types of colors into the phosphor and all of that, but you have to be careful because it produces certain nanometers of color that can affect different things. So it's a very close balance, and it's just something that we're working on, all the time.
And noticing the spike in the blue here, that's common with most all LEDs, correct?
Yes, it really is. And so here you look at it, but we don't have a side-by-side comparison, but this lamp produces luminous flux, or the amount of lumens, 640 lumens. And it's producing 100 lumens per watt with a power factor of 0.92. So drop down and look at your VA and your power. Your wattage is actually 6.34. Your VA is 6.9. So the amount of wasted energy is basically, let's call it 0.5 watts of wasted energy. And, then again, we're at a 91 CRI with our lowest being R9, which is the most difficult to achieve. So, at 100 lumens per watt, this is pretty decent.
Very good.
And so then you look at our TM30, and now for the first time you're seeing the reference circle, which is in black, and the measured circle, which is in red, of our particular lamp. And it looks like we're oversaturated with some colors and undersaturated in others. And it's, again, trying to get that thing as close to halogen as possible. And this TM30, as I mentioned before, this measures like 99 different colors. One important thing to note that, you know, you can have, let's just say a 3000K lamp. And you'll get some color shifts in one direction or the other, but that 3000K lamp could look a little bit more rosy or can look a little bit more blue than others, but it still falls under that 3000K, you know, spectrum. So, or specification. So that gets into binning and all of that. We're trying to create, you know, every single one of your products as close to the other one as possible, where there's no difference from lamp to lamp.
Very good.
So this is like one of our competitors, and you know, it's not a bad, you know, looking curve. Where they fall, and where most people fall out, especially not paying attention, is in that R9. In their R9 is, you know, at 9.5, and I think ours is up around 50 some. It's tough to do, but it's very important to get those reds in that LED elevated.
Right.
And so then we look at their overall color. I mean, they're at an 81 CRI. Their amount of lumens is 576. They're only putting out 81 lumens per watt. The amount of power, excuse me, one below that power factor is 0.58. You know, then where ours was at like 0.91. So then you go down to the VA. I mean, the VA and the power. So the power is, you know, the amount of energy that's used to make the actual light is 7 watts. The VA, the amount of wasted energy here is 4 watts. And so what happens when, you know, somebody uses these types of lamps is that you can, for every 2 of these lamps that you would use, you could use 3 of ours and draw the same amount of energy.
Hey, Mark, can we stop this just for a sec?
Yeah,
People, when they're,
go ahead.
So competitor B, all y'all, is brilliance. Do not confuse it. It is brilliance. Okay, Mark, go ahead.
Okay,
You know, it's true.
yes,
Yeah,
thanks, Mike.
they're going out, and it doesn't matter if they're going to buy bulbs, integrated, or anything else like that. If you want to buy a, you know, high power factor, low VA product, you get the biggest bang for your buck.
Right. A lot of foam on this beer.
Yep, a lot of foam.
a lot of head on the beer.
And so you can see the under and over saturation on this. And so this might look a little bit more blue in certain areas and a little bit less red and, you know, green in others.
Okay. Because you're using this outside here, your reference color wise to see this, whether it's less, whether it's more.
Correct. The black circle is your reference point.
Correct.
And then each one of those.
So the black circle, sorry, Mark, the black circle is where he wants to be, correct?
Yeah, that's the acting as the halogen. That's
Okay.
the model standard to try to shoot for. And then
Correct.
what
Okay, I've got it.
saying the red is what is actually produced by whatever lamp brand it is. Then
Correct.
you
Yes, sir.
see the color around this whole chart here. See, like
Mhm.
here's oranges, then it's pinks, and then it goes to reds, whatever.
Right.
So then you see these white rings. So
Mhm.
anything that's outside, like, is more, I believe that's positive. Um, I can't see here. And then anything on the inside is less or negative.
Yeah,
So
yeah.
that's kind of how it works.
It looks like it's weak all the way around, good portion of the spectrum.
Yeah, that's why I was saying like some of the greens and the blues. See, it's a little
Yeah,
weaker. And same
yeah.
with that pinks and orange, whatever.
So this TM30, this is sort of what's going to be the
That's
new
right.
CR in the future.
I guess that's it. It sounds like from what Tom was saying is that this is where the future is going.
Mhm.
IES, I'm sure, is pushing all of this, and those maybe who knows, maybe ANSI. I don't know what standards, how they determine which ones to use, but those are the big guys that decide all this.
10-4. Thank you.
Mhm.
PM30, very good.
PM30. So here you get a little bit of a better understanding of halogen, Emery-Allen, and then our competitors as far as how the colors are being handled.
Yep, and you can see that clear difference with the reds, like you were saying, and
Sure.
others. Yep. Nice.
And then here's the ultimate outcome of that is, with our product up on top, um, what you see is white. If really squint your eyes and look, you can see a little bit more warmth or yellow down towards the bottom. And you look at the one below it and, there's a lot of stuff going on there. There's a lot of different colors and all of that. And, you know, somebody might be able to get away with this and with foliage,
Mm-hmm.
but you certainly can't get away with this when you're lighting up architectural elements, sides of houses or buildings or something like that.
Absolutely. Great.
So in order to get in order to really achieve the higher numbers and all that, it all starts with product development. And we tell everybody that everything that we produce is designed for a specific application in mind, but it's all designed from scratch. And we test it and test it over and over and over again. And there's a lot of guys out there that are doing this, whether it's with integrated or lamps or whatever. But the amount of testing, the amount of manufacturing QC that you have to do is pretty incredible. It's a lot harder than making, an incandescent bulb.
Mm-hmm.
And then this just shows artificial aging test. The picture on the left is a conveyor belt gets loaded up with lamps. One revolution, depending on how fast you move it, would either happen every 4 hours or every 8 hours. And the only thing that this is doing is catching things in the manufacturing process that could have possibly gone wrong. And typically it's solder joints that aren't done properly or whatever. And this will catch like close to 100% of everything that has failed. Now the picture on the right, it's a little bit difficult to see, but this carousel that has, I think 6 different lamps loaded into it. And each of the different lamp devices shoot up into that small integrated sphere, and it's measured. And we do that with every single lamp to make sure the consistency of the product is exactly what it should be. And this is done after the artificial aging test. So, like I said, it's a lot of work that goes
Yeah, I was
in.
gonna say, that's pretty impressive and time consuming for sure.
Sure, yeah, absolutely.
Wow.
And then, it's also the extreme product testing where, we take our MR16s and put them inside of a brass fixture, turn it up. It's a 7-watt fixture. Turn the heat chamber up to 125 degrees Fahrenheit and see where the failure points. And surprisingly enough, the failure points on this that quite a long time. And it happens to do with the polycarbonate lens. You wind up cooking out all the moisture after about a year and a half or so. LEDs are still operating fine and all of that, but it's within the polycarbonate. And the other one on the right hand side is just we threw some things underwater in an aquarium and seeing what would happen in fresh water. These things are going to last a long time, but when you start and you, just like anything else, you have moisture, and then you remove the moisture and you have the possibility of corrosion entering into things and all that. We don't recommend people run this stuff underwater, but it just shows that our products can take exposure to moisture without any real problems.
Right. Now, I know we're going to talk a little more about materials and quality of construction and things like that, but just real quickly, I mean, I know your housing or here on the LED, it's ceramic, correct?
Correct.
Versus a lot of the other ones might be more, whether it's plastic or aluminum or some of the other. Can you talk a little bit about some of the material types chosen there and why because of this?
I mean, do a little bit of research on ceramic, and there are different alloys of ceramic that do a lot of different things. They use to make artificial hips, things like that, and they use ceramics for heat sinks and whatnot. And the type of ceramic that we use, is an alloy. There are different materials that are in there that actually help manage the heat a lot better than any other material. And this particular alloy of material dissipates heat better than aluminum or brass. So we don't color it, we don't tint it, we don't paint it, we don't do anything to it, because the most important thing is to LEDs, at least what we believe, is you have to manage the heat and you have to manage the current. And if you don't do that, if you don't do either of those things to an LED product, you're going to have problems. So,
Wow, right. I guess that kind of ties into part of this here.
yeah, and then there's, a lot of the things that we do goes to the California Energy Commission, the CEC with Title 20 and Title 24 and all of that. We have turtle safe or wildlife safe bulbs. I don't know what they're calling them. And then, on top of that, everything has gone through Lutron testing and certification to find out how the products are going to work with a lot of the different types of systems that the dimming companies have. And so we, probably was happening concurrent with the whole Title 20, Title 24 things. We were submitting things to Lutron to make sure that all of this stuff is going to work out. So, you know, those are obviously, you know, the big ones here.
Mhm. And it's the higher bar standard out in California with all the rules and regulations. So if you can successfully fulfill those requirements, then you're basically ahead of the game on many of the other states or other countries or whatever the case may be, correct?
Sure, absolutely. You know, just quick story, when we, you know, maybe a year into Emery-Allen or something like that, one of the big things that popped up was Title 24 JAA compliant, which the first time it's a performance standard and it's a quality standard as well. You know, you look at UL or any other agencies and they're strictly after safety, they're not after performance, but you know, California was really pushing performance and overall quality. And we probably spent a year and a half getting things through CEC testing, and that or CEC certification, that included testing as well. And we went on a webinar with somebody about halfway through this, and you know, they were asking, you know, state of California, it's one state, you know, you got the rest of the US, Canada, and all of this. What are you going through all this stuff for? And you know, I told them, I says, you know, but when we're all said and done, it really made us a much better company. It made a much better bulb. We understood a lot of things that we might not have understood if we didn't go through all of this. You know, it really took us to school as far as what we had to do in order to meet a lot of these types of things. And now, you know, we are certified with a lot more dimming companies than Lutron. We're in, you know, a lot of different hospitality and casinos and stuff. And that's all because I believe that we were forced to go through this thing. We weren't forced, we elected to do it. It was a great thing to go through, because it just made, you know, made us make a much better product for the consumer. So glad we went through it. Glad I don't have to do it again.
There you go. Nice. All right. Well, and this is your contact information. I thought we'd throw this in here just in case anybody has questions or they want to look into your products to purchase. Your email, tomg@emeryallen.com, phone number, any other things or thoughts that we can leave people with? This is only session 1. We have session 2 coming up next.
Yeah, no, I think this is good. You know, I just say, you know, you want to see a little bit more of who we are and who we deal with and all of that. Go on our Instagram. I mean, we try to get as many customers as possible to submit photos of installations and jobs. And, you know, if I didn't mention before, you know, landscape lighting is just a small part of our overall business. You know, majority of it's in interiors, you know, exterior types of lighting and specialty lighting and all of that. And check out some of the photos, because especially some of the ones recently. There was one that we have a customer up in Vancouver that makes these little glass orbs, and some of the things that they can do with this just pretty incredible. But
Yeah.
I encourage you all to go on our website, and not only that, but you know, on our Instagram page and see that. And then I mentioned our website real quick. You know, our marketing guys have done a lot of work, a lot of hard work to get, you know, educate people as much as possible about LEDs. And there's a section on there about with blogs, and it's mostly educational blogs how our bulbs work, how they function and all of that, what you can do, what you can't do. Talks about everything from electronic dimmers, electronic transformers, magnetic transformers. When you're using that, on the inside, we have a lot of references off to some of the white papers that Lutron has and all of that. So it's a lot of great information that, our guys have put together so that people, understand, how to use these things. So please utilize them.
Awesome. Well, thank you, Tom, this is session 1. We'll be right back with session 2 here next.
Sounds
Thank you.
good. Thank you.
All right. So there you
Nice.
go. That was the first one. Do you have any questions or any thoughts or things that we should explore? Anybody? Uh-oh.
I
Rick,
do know that they have an FCC, higher FCC compliancy whenever it comes to garage door openers. A lot of LED lights that are in garages now or on the exterior of a garage can actually interfere with the frequency from your remote control and cause issues with it.
yeah. Actually, Tom will be talking about that next
Yeah.
week's session. So that's good. Great point.
Yeah. Yeah.
Anybody else? Rick, were you going to say something? I saw your lips moving there. No, you're still muted. Can you hear us? Oh, I guess he's trying to figure it out. All right.
Okay, real quick, Mark.
Yeah.
The Vancouver company he was talking about that has the orbs, that's I think it's called night orbs or whatever. I've bought a couple of those and they're very cool. Okay.
Yeah.
Chris Mitchell has as well.
Oh,
They're
nice.
little pieces of artwork and they have Emery-Allen lamps in them and they're cool. They're mostly circular and colorful pieces of art you could hang in trees or whatever. So yeah.
And
It's
who makes that?
I think it's called night orbs.
Okay.
And
There's Oregon's
be
a big, they do a lot of that in Oregon where they call them Oregon floats. Where
right.
they
that's-
actually they blow the glass orbs and then they throw them out in the ocean. They have a big festival and everything and let them
Right.
roll back in on the beach and then people collect them and
right.
it's pretty
But-
cool.
but
They're beautiful and they can light them
Yeah.
up. Nice. Yeah.
When we were in Owensboro, Chris Mitchell had a sample of that, and I remember him saying that, and it was really cool. It's just very colorful, 12-inch orb, and he said they were putting it in one of his clients because he had a special needs child that really liked those. Okay. And so therefore, Emery-Allen puts the lamps in those. So it was very cool.
Nice.
Yeah.
Mark, can you hear me now?
Yes, there you go. Thank you, Rick.
Okay. Yeah, I was trying to do the Pink Floyd song where it says your lips are moving, but nothing's coming out. But anyway, my question is, does Tom and Emery-Allen, have they done any research on what LED lighting is doing to the environment, such as birds and such as that?
That was one thing I did not ask him about that, but I should have. That's a great question. What I'll do for our next session, I'll reach out to Tom and I'll ask him if he has any input on that. And I'll see if I can share that this next time.
That's a good question, guys, too.
Tim Ryan has done a little bit of study on that. But yeah, I'll just be curious.
Okay.
Find out which ones attract insects and which ones insects aren't interested in.
Exactly. There you go.
George, I tell all my customers just take up smoking, and that takes care of that. So.
They'll get lung cancer and die.
Yeah.
Hey, George, I just shot you a message on Messenger. I'm not sure if you got it or not, but just want to let you
I'll
know.
take a look.
So Mark,
Yeah.
at the end of Tom's spiel, he did say something about the lamps are turtle friendly. Okay, I remember that. So
And they're using, that's where the 2200 Kelvin,
Yeah,
those
yeah,
really
yeah.
warm amber orange
right,
color,
right,
that's more falls in that line.
yeah.
So yeah, I'll try to get some clarification on that towards insects and bats, birds, animals at night, nocturnal, like, because there is, I know
And
that's been a big area. And like, I think Rick was saying about Tim Ryan's been doing some studies on that to
Yeah.
try to get some clarification, because that's something I think that is unknown. There's not, and nobody we don't know what the real answers are.
Yeah.
Because
And-
depending on who's doing the studies, they'll skew it one way or another.
Right.
and flowers, whether it works, makes the flowering happen at the wrong time of the year or whatever,
Yeah,
flowering for trees.
I can tell you that 3000 Kelvin, I had some crepe myrtles that I wrapped for a company. It was outside of the Louisiana State Archives, and they were some fairly mature crepe myrtles, but I wrapped these crepe myrtles for about 4 years. And that particular light seemed to accelerate the growth in the trees vertically and also in circumference of the trunks, because they were snapping the light strands at nearly 10 to 11 months, and I was going out and having to replace them almost on an annual basis. It seemed like the growth was getting a little out of control.
interesting. Wow.
Well, and I live just north of San Antonio here, which is Military City, USA. And these people out here freak out over dark sky stuff. And
Yeah.
so there's question always comes up.
Yeah.
Good. Any other questions, thoughts before we cut her off?
Where do they manufacture their lamps?
North Carolina.
Oh, okay.
Mhm.
Let me see if Alex had a question. She had to leave, but she's curious to see charts of performance after some life cycle examples. After being in the field 8 months, made it through the summer, then I replaced the lamp next to it. How does the new one look next to the 8-month-old? So the aging process. And I think he talks a little bit about that too. But typically, I believe most LEDs are what is it, TM70 or LM70? I forget what it's called.
Yeah.
But once they reach a 70% output level, that's when they consider that's the life expectancy. He'll talk about that next week more. So hopefully that will answer some of that.
Oh.
All right. If you don't have any other questions, let's call it a night, and thank you for joining, and we'll see you next Wednesday for part 2.
Thanks, Mark.
Sounds great.
Very
Thank
cool.
Hey,
Yeah.
Chris, I didn't get your email. I didn't get your message.
Oh, you must be talking about me.
Oh, Olin.
Mark, after we get off, can you get me George's email or his number so I can reach out to him?
Sure. No
Yeah, I'll
problem.
give it to you
Okay, I
right now.
appreciate
It's 561-762-5800.
561.
762
Uh-huh.
5800.
Got it. Thanks, George.
You got it.
All
Well,
right,
have a
guys.
great evening.
Thank you.
Take care.